Okay, so let's start. We will present our new results on the key performance indicator to track the transition to zero emissions in the European automotive industry. This is actually a follow-up study. So to the left, you see a link to our flagship study that we executed for ACEA, in which we actually did a deep analysis into all barriers and gaps to the transition of zero emissions for passenger cars and vans. So the QR code leads to that comprehensive report. Today, I'm going to present the follow-up study in which we develop key performance indicators to track the transition, to track the progress in the transition. This will be a quarterly exercise in which we monitor really how the transition to zero emission vehicles is going. So that's the QR code to the right that gives you access to the full report of our new study. So basically, what is new for the ones who already know our previous study that we published last year? Well, first of all, obviously, we updated the data. So all the key performance indicators in our study are based on most recent data. What we did compared to the previous study is that we, for each critical aspect in the transition to zero emissions, so the readiness of the electricity grid, consumer adoption, recharging infrastructure, and manufacturing, we identified key performance indicators for which we set measurable targets based on the targets of the European emission to have all zero emission vehicles by 2035. These KPIs will be monitored on a quarterly basis so that we can track the evolution, and it's on country level. So we collect data for each of the European countries. That's all in the report. Today, I will present the result based on European averages that are assigned with traffic lights, whether they meet the targets. And this time the traffic lights are clearly and objectively defined. So how we get to a red light, an orange light, and a green light, that's all explained in the report. What else is new? We have developed a total cost of ownership tool that we can better track affordability. So the unique thing about our tool is that it also will be quarterly updated. So most existing TCO tools use static data, and as soon as something changes, for example, in terms of prices of electric vehicles, fuel prices, or the fiscal context, then the TCO tool is actually no longer up to date. We will update our TCO tool with the newest data such that we can really track the affordability of electric vehicles. So the idea is that we have this quarterly update such that we can really do good monitoring. In terms of scope, we cover passenger cars and vans, so only light-duty vehicles. And for zero emissions, we cover both battery electric vehicles, and we also have indicators for hydrogen. But the core of the analysis, the focus is more on battery electric vehicles. So what will I do today? I will present you with the European averages of the KPIs, so the traffic lights, and for each of the four key areas, I will pick out one indicator for which I show a little bit more detail, but please have a look at the report where we have the detailed analysis by country for each of the indicators, because there's quite some diversity across countries. So for the readiness of the electricity grid, we identify key performance indicators in three areas: the grid stress management, smart charging readiness, and the quality of the grid. And if you look at the traffic lights, you actually see that the European electricity grid currently is not yet ready for the expected increase in demand, and especially the peaks in demand due to electric vehicle charging. So for grid stress management, we focused on the capacity of renewable energy, more specifically solar panels per light duty vehicles. And this is actually an indicator I want to point out today. So what we measure, we calculated actually based on the average energy consumption of an electric vehicle per year and the production of solar panels per installed capacity. We computed the required solar capacity per electric vehicle. So that's 3.2 kilowatt per vehicle that is required to be able to provide solar energy for the operation of your vehicle. So the target is this orange line on the graph, and you can see that none of the European countries at this point meets the target in terms of solar panel. The Netherlands and Germany actually have the largest capacity, but most countries are far away from the targets with this respect. With respect to consumer adoption, we focus on the availability of zero-emission vehicles and the affordability of zero-emission vehicles. And on a positive note, compared to our previous report, we can say that the number of available models with a retail price below 30,000 has increased considerably compared to the previous year. So in June 2024, we had 7 vehicles available. Now we have 15, so more than doubled. And already 2 models have a purchase price of below 20,000 euros. So that indicator, although it's still a low number of vehicles with an affordable price that is on the market, it's at least evolving in the right direction. Still, when we look at the adoption rates, so the share of new zero-emission vehicles in total sales, we are still far off the European target for 2035, and this is especially the case for light commercial vehicles, where uptake levels are still far below the target. And part of the explanation for this relatively slow uptake is that there are still some affordability issues with respect to the zero-emission vehicles. And therefore, I want to focus on our TCO tool that we developed. So this is actually a quite interesting picture here from which we can draw a lot of conclusions. So let me explain what you see. You see the ratio of the total cost of ownership of a battery electric vehicle over that of a comparable petrol car. And we do this for 4 vehicle segments. So the mini cars, the really small city cars, small cars, medium cars, and large cars. So it's a ratio. So when the TCO ratio is above 1, it means that the battery electric vehicle total cost of ownership are higher than that of the petrol car. So above 1 is not good. When it's below 1, it means that the electric vehicle is cheaper in TCO terms. And the 3 different bars account for different charging profiles. So the dark green is an electric vehicle that relies on private charging, and the light green and gray bars are 2 public charging profiles. So you actually see that people that rely on public charging are worse off in cost terms. What are the main takeaways from this chart? Well, basically in the small car segment, especially in the mini car segment, we see that electric vehicles are still significantly more expensive than comparable petrol cars. And this is one of the main explanations why, for example, in Italy, where we see that the electric version is up to 50% more expensive than the petrol car. Why in Italy this uptake of electric vehicles is so slow? Because in Italy historically there's a strong preference for small cars, given the narrow routes, but they are still much more expensive. So for small cars, the ones that should be affordable, there are still major affordability issues. It's not the case for large cars. For large cars, the TCO of the electric vehicle is already more favorable. And we also see the particular situation of Spain, for which small cars are more affordable, and that is thanks to the quite generous purchase subsidies that are provided through the Moves 3 program. So there is a quite high purchase subsidy that leads to a significant reduction of the upfront cost, the purchase cost of the vehicle. That is actually the main barrier, especially for the small vehicles. However, it also shows that affordability alone is not enough, because even though these small electric cars in Spain are more affordable, electric vehicle uptake in Spain is relatively slow, and that brings us to our third critical area of the zero-emission transition, and that is recharging infrastructure. So it's not sufficient to have available and affordable electric vehicles on the market. The recharging infrastructure should also be fully deployed and efficient. So with respect to recharging infrastructure, we actually have a mixed picture with our traffic lights. So on the one hand, we see that in Europe, most countries meet the ACEA targets with respect to public charging capacity. We see that there are quite a high number of public charging stations overall. But when we look at the other indicators that measure the disparities in public charging infrastructure, so differences in charging density, both between countries, but also within countries, and the share of slow charging versus fast charging, there we see that there are still important issues. For example, here you see the share of slow chargers in light green versus this share of fast chargers in dark green for the different European countries. And a very good example is, for example, the Netherlands, because the Netherlands stands out in terms of number of charging points and in terms of charging capacity. So it's always best in class when we measure it based on that respect. But then when we look at the share of smart chargers, we see that in the Netherlands, nearly all charging points are slow chargers. So that's the case in most countries, that the share of fast chargers is really relatively low. Turkey actually gives a bit of a false picture, because it shows up in this indicator as best in class. So it has a relatively high share of fast charger, but that just means that in Turkey there are relatively few chargers, and the few chargers that are there are along the highways, and those are mostly fast chargers. So it does not mean that in Turkey the charging infrastructure is so well deployed. To give you a comparison, the black line on the figure shows you the share of fast chargers in China, which is about 50%. So in other major markets like the US, like China, fast chargers have a much higher share in the total charging infrastructure. And this is really an issue in Europe because several consumer surveys indicate that consumers are not satisfied with the charging network and that charging takes too long. So there is definitely a need for more fast charging. That brings me to the last critical area in the transition, and that is manufacturing. On the manufacturing side, we look at energy costs and battery production capacity. With respect to energy, so all these indicators actually are in the red. So huge challenges for European manufacturers with respect to competitiveness. Energy costs are still multiple times those as in the US and in China. And also in battery production capacity, we are far from the target to be self-sufficient with respect to batteries. So what you see here is the capacity, the maximum production capacity that is currently in operation in the dark color. We've added the ones that are under construction, so that will become in operation over the coming years. The target is calculated based on the production capacity that we should have if we would equip all European produced passenger cars and vans with European produced batteries. So we see that we are still very far from the target with that respect. So that was a very brief overview of the indicators that we are tracking. What we actually do in this report is that we take, so we focus on the full zero emission transition ecosystem. We focus on 4 critical areas in this transition, and we track progress in all of these areas simultaneously with the purpose actually to see in what areas action is needed the most and in what areas progress is being made.